Exoplanets, planets around stars other than our sun. This is perhaps my favorite area of astronomy, and I'll explain why as we go along. First, these were originally called extrasolar planets for a short time and in the late 90s, and it seems like they've gone to the shorter version of just calling them exoplanets. Now, keep in mind, we grow up watching movies, and we just assume there are planets out there. But when, Star Trek came out in the 1960s and they visited new planets every week, we'd never discovered an actual planet around another star. When Star Wars came out in the 70s and 80s, same thing. We actually hadn't ever confirmed any planets around other stars. It wasn't until 1995 that we finally had evidence of the first planet around a sun-like star. And there's a very interesting story behind this. There were a couple American astronomers, Geoff Marcy and Paul Butler. And Geoff Marcy had reached a point in his career where he felt like he was going nowhere. And he decided to take a chance and go into this field that a lot of people thought was sort of career suicide, that this was a dead-end street at this point. But he went into it anyway. But he did make one big mistake early on. The conventional wisdom at the time was that other solar systems would be very similar to our solar system. We have 4 small rocky planets close to the sun, followed by 4 large gas giants. Astronomers at the time didn't think it was possible to have large planets close to their host star. Those would be the easiest planets to find, but they just didn't think they existed. Well, the Swiss team ignored the conventional wisdom and went looking for those kinds of planets. And in 1995, they found a very large planet, a Jupiter-like planet, around the star 51 Pegasi. So it became called 51 Pegasi b, and that planet, the size of Jupiter, had an orbit of 4 days. For comparison, Mercury takes 88 days to orbit around the sun. So this obviously was incredibly close to its host star, and it blew away the conventional wisdom. We had no idea that planets like this could even exist. And so anyway, the American team were kicking themselves at that point, and they looked back at their data and immediately found 6 planets in the data right in front of their face. And they could have discovered those 6 planets before this Swiss team discovered theirs, but they didn't look for the obvious. They listened to the conventional wisdom. So I think it's a very, very interesting story. Now, I started my astronomy class in the fall of 1997. There were 8 exoplanets. Today, in 2015, there are well over 2,000 confirmed exoplanets, and the number is expanding all the time. I'll mention that American team right here, Marcy and Butler. Their first one was in December of 95, called 70 Virginis. Anyway, I just think the early history there is pretty interesting stuff. Now, early on, there was only one method available to find exoplanets. First, we're going to listen to Geoff Marcy here talk about his discovery. Now, obviously, that's an old video. He talks about finding 100 exoplanets, and we're well beyond that now. But he talks about the goal, sort of the holy grail of this field, finding an Earth-like planet. And in 2015, we are incredibly close to that goal. The Kepler team just announced that they had found an Earth-sized planet in the habitable zone of a star for the first time ever. So we're very, very close. That doesn't mean it's Earth-like necessarily, but it's a very big step in that direction. Now, you notice that Geoff Marcy mentioned the wobble of the star 70 Virginis, and that brings us to our first planet-finding technique. The wobble of a star produces a shift in its spectral lines. And this shift towards the red or towards the blue, of course, is a Doppler shift. And when we see a star shifting, basically when its spectral lines shift from red shift to blue shift to red shift, as it wobbles towards us and away from us, that's how we know that a planet's there. Now, of course, a heavier star will cause a heavier planet, a heavier exoplanet, will cause a star to wobble more. That's why they're easier to find. Okay, a heavier star, a heavier planet will cause the star to wobble more. And actually then we can calculate the mass of a planet based on the amount of wobble. So this is a very, very important technique. And early on, this was the original technique for finding planets. So we'll call it the Doppler method, where it's a Doppler shift of the light. As a matter of fact, if the planet is tugging hard enough on the star, the actual star itself can be seen to move against the background. I don't think that's the typical method, but that's possible as well. So the Doppler method, you have an exoplanet tugging as it goes around, as it orbits a star, tugging that star back and forth, and we can see the shift. Okay, an early satellite launched by the European Space Agency was used this technique. It was called Karot, and they were very successful, and they started finding much smaller planets than were possible in the years leading up to that particular mission. Anyway, let's take a look at the picture here very quickly. Now, a star is not going to normally be making a big circle like that in the sky. It's just going to usually just wobble a little bit in a much more subtle way. But the point is that when it wobbles towards us, you see when it's coming towards us, the wavelength of light is sort of scrunched together a little more, and we call that a blue shift. And when it wobbles away from us, the waves get spread out a little bit, and that's called a red shift. And that is to this day, a very important technique for finding exoplanets and also calculating their mass. We'll find out about another technique in the next lecture. Thanks for listening.